So in order to get writing some JavaScript, you're going to need something on your computer that will actually take the JavaScript code and actually tell the computer what it needs to do. And luckily for us though, JavaScript runs pretty much everywhere now. And luckily because it's a web development language, you can pretty much run it in any browser from what we call the developer tools. So in order to write a bit of JavaScript, all you need to really do is open up the developer tools for your particular browser. I'm using Chrome here. And you'll find an inspect or developer tools option present, which allows you to do many fascinating things. But if we go over to the console, here you have an interactive JavaScript environment where you can actually write any JavaScript statements and the result of the statement will be repeated back to you. So the first thing that most new programmers do with a new language is the Hello World program, which is literally just displaying the text Hello World back to you. And here you can see I've written a JavaScript statement which has just printed Hello World back to me on the console in Chrome. And if you're using a Mac, there's something you can use which will make writing your JavaScript even easier, and it's a program called Run.js. So if you literally go ahead and Google the term Run.js, and the first result that comes back is a project which basically allows you to run JavaScript directly on your Mac. So if you go ahead and download that onto your Mac, you can actually run JavaScript right on your desktop. So the program itself, once you've installed it, it looks a little bit like this. So we can actually just write in our Hello World JavaScript statement again, and you can see the result is printed out on the right hand side for you. So go ahead and use whichever you feel comfortable with. Obviously, if you haven't got a Mac or if you don't want to use the Run.js program, you can just do it on the console of your browser, just so that you can see the JavaScript statements that I'm typing in. So before you start the next lesson, make sure that you know how to run some JavaScript and try that console.log hello world. And when you're ready, you can move on to the next lesson. So in the previous lesson, we got you set up writing a bit of JavaScript in either your web browser console or in the Run.js console if you're on a Mac. And we literally printed the message hello world back to ourselves in the console. And we used this console.log statement. So every instruction that you give JavaScript within your code is referred to as a statement, and it's usually a single action. And in our previous case, it was to log out hello world to the console. So there are a few things that you should be aware of when using the console. So it doesn't matter if it's in the web browser as well. You can use this console.log statement to print out text and numbers to the screen, but because we're in a REPL, which stands for read, evaluate, print and loop type of environment, we can actually just type in things directly without using console.log. So for example, if I wanted to type in hello world again, you'll see that it's just repeated back to me in the console. And we can do the same thing with numbers as well. So you can see adding 2 and 2 together gives us 4. And we can do other mathematical operations too, by the way. So for example, if we say 2 and then an asterisk and 2, that's 2 multiplied by 2. And then if we wanted to divide, we use a /, so 2 divided by 2. And of course, if we wanted to subtract, we just use a minus sign to give us 2 minus 2. Okay, so the thing to take away here is that when you're using the console, whether it's in the browser or with Run.js, you don't actually need to use the console.log to get some output onto the screen. If you're writing code that's going to be within an application or within a website and you for some reason want to log something out to the console, maybe there's some kind of error occurred or something, then you would need to use console.log, but let's not worry about that too much for now. Of course, we can use console.log for our numbers as well, so we could put our sums inside there too. And you'll notice I've used a semicolon at the end of that line, and that's to tell JavaScript that we've finished our statement. So we've told it we've finished what we're doing. So just to give you an example, if we were to put another console.log here, we could actually put those both on one line. JavaScript will let you do that. It'll let you put more than one statement on a particular line. But if we forgot to put that semicolon in there, for example, you'll see we get an error because JavaScript can't understand where the first console.log ends and the second one begins. So a couple of good practices. First of all, when you write your statements, make sure they finish with a semicolon at the end, and you might as well put each statement onto a separate line. There's no reason to squish everything together. The aim is to write the source code of your program that you're writing as readable as possible. So you'll notice when I want to do some arithmetic or print out some numbers to the console, I don't need to wrap those in single quotes. So when I'm working with text, like the hello world message above, it needs to be wrapped in quotation marks. And we refer to this text as a string, and you can see it's got spaces in there, so the quotation marks just help JavaScript to identify where the complete string is held, and obviously the numbers don't have spaces in, so we can safely not use quotation marks around those. We'll actually look at data types in JavaScript in a couple of lessons' time, but first let's talk about what variables are and the difference between the three ways of declaring them. So in this lesson we're going to talk about JavaScript variables, and if you don't know what a variable is, it's basically a way of storing a value in a name and updated and passed around to do different purposes. So in the previous lesson we did some mathematical operations like 2 times 2 for example. We can actually save the result of that into a variable and use it somewhere else in our program. So the way we define variables in JavaScript is to first of all use the var keyword, and then after that we basically give our variable a name, so we say something like number, and then we use a single equals sign and then write the value that we want to assign into the variable. So anything on the right hand side of the equals sign actually gets saved into the variable that we've called number. And now within our code, anywhere where we access the variable name, you can see we can access that value that's stored in there. So the word var is a reserved keyword, so it's kind of like a word that you can't use as a variable name in JavaScript. So for example, if we wanted to create a variable named var, you'll see JavaScript won't actually let us do that. So you need to make sure that your variable names themselves don't actually conflict with any of the keywords in JavaScript. And you'll learn more about those as you go through the course. Of course, we don't need to directly assign a number there. We can actually assign the result of a mathematical operation, and we can store pretty much any type of data that we want into our variable names. So here I've created another variable called string, and you can access it just by referencing the string variable name. So there are actually a few different ways that you can declare these variables in JavaScript, and var is kind of like the old way of doing it. The reason I've showed you it is because you might come across it in some older code bases, but the standard way of doing things now is not to use var but to use another keyword which is called let. And as you can see, we can simply replace var with the let keyword and everything continues to work as normal. And there is a subtle difference between let and var, which will be explained in a later lesson for you. So just because we've assigned a value to these variables doesn't mean that they're kind of fixed. We can actually change the value that's stored inside them. So if I wanted to assign a new number to the number variable, I could assign that the value of 10, for example. And you'll see on the right hand side that number is now equal to 10. And we can do the same thing with string as well. We can just literally assign it a new value. And with numbers, you can obviously do those arithmetic operations again. So we could say 10 times 2, for example, and number now has the value of 20. And if you want to increase the value that's currently stored in number by a certain amount, you can simply assign the value that's currently stored in number back into number plus the additional value that you want to store. So if we wanted to increase number by 5, for example, we could write something a bit like this. There is a shorter way of writing this, which you'll probably come across as you go through your coding journey, but you can simply say number is plus equal to 5, and you can see that has the same effect as this previous statement that we had. So there's one final way of defining variables, and that's using the const keyword. So for example, if I created another number, this works exactly the same as let and var did before. I can access the another number variable from the console. But the key difference with const is we can't actually reassign the value that we've already assigned to the variable. So what I mean by that, if I wanted to assign 20 to the another number variable now, you'll see I get an error in the console saying that I can't assign to a constant variable. And that's because const is short for constant, which basically means we can't actually change the value once we've set it. So that might seem a bit restrictive, but it's quite useful in creating code where you assign a variable and then you don't try and accidentally update it later on. It just helps you to write safer and better code. So the key thing to take away is if you want to hold a value that's going to be updated multiple times throughout your program, then you're going to need to use the let keyword to define a variable. But if it's something that's going to stay static and it's not going to change, then use the const keyword. So there we have some different ways of creating variables in JavaScript. Take some time now to jump onto your console and have a go at creating some different variables and reassigning those values to them. And make sure you understand the difference between let and const. In the next lesson, we'll look at some of the other data types that are available in JavaScript and how you would assign those to variables in your code. So in the last lesson, we learned how to create variables in JavaScript using the let and const keyword, and we saw some of the different types of data that you can store in your variables. In this lesson, we're just going to run through the different types of data that you can use in JavaScript and how to identify the type of data that's stored in a variable. So I've got two variables defined here at the moment, age and name, and it should be fairly clear that the age has got a numeric value and the name variable has got a text value stored in it. So we can say the data type of age is a number and the data type of name is a string. And we can check that using the typeof operator in JavaScript. So on our console, if we type typeof age, you can see in the output on the right we get the value of number. And if we do the same thing for name as well, you can see we're being told the data type of name is a string. So really whole numbers and strings are kind of the most common data types that you'll come across in JavaScript. But what about decimal numbers? So numbers that have got a decimal point in them. So let's just create another variable up here and we'll call it bank balance, for example. And we'll set that to 3235. And you can see the console's quite happy with that. Let's try and get the type of that data now. And so JavaScript just tells us that the type of bank balance is actually a number as well. So there's no distinction between a whole number, an integer, and a decimal number, a floating point number. So what about if we've declared a variable but we've not actually assigned it a value? So we could have something like a variable called nothing here that has no value. If we try and get the type of that now, you'll see we get this special undefined value come back for its data type, and that's because we've declared the variable, JavaScript knows about it, but we've not actually assigned a value to it yet. So JavaScript's letting us know that the variable's there, but it doesn't know what data type it is because we haven't given it a value yet. So there is one other type of data type that's quite important for us in JavaScript, and that is the object data type. But an object in JavaScript can be so many different things that we're not going to delve into what they could be here. There are different types of things that can be an object, like an array, an actual object literal, and a function, and we're going to cover those in separate lessons later in the course. So hopefully this lesson's given you a bit of an overview of the different types of data in JavaScript and how you can find out what particular type of data a variable is holding, as we'll look at how we can convert between the different types of data. So there is one final data type that I thought it was worth doing a separate video on, and that is the Boolean data type. So a Boolean data type is something that can either be true or false. You can think of it as either being on or off, like a light switch. And it's something that's incredibly fundamental to JavaScript and to many other programming languages as well, because you use these Boolean values to base your decisions on. For example, is a user logged in? If it's true, then you can give them access to a certain resource. Does a customer have their email sending preferences set to true? If so, we're allowed to send emails out to them. You can see by having these true or false values, we're able to decide what our JavaScript program should do, and we'll be looking at how to do this later on in the course using if statements. We'll also be looking at how to create a Boolean using something called a Boolean expression, which is basically the result of comparing two values together. So for example here I've created a variable overdrawn and I've actually assigned it the value of true. But what I could do is say set the value of overdrawn equal to the balance and check whether it's smaller than 0. So this balance is less than 0 is what we call a Boolean expression, and when we come to look at if statements we'll dive into these in a bit more detail, but I just wanted to show you that you can set a variable to true or false, but it's more common to be assigned from the result of a Boolean expression like this. So as I say, Booleans and Boolean expressions are really crucial and fundamental to JavaScript development, so you'll be learning lots more about them as the course goes on. So in the previous video we looked at how to create different variables and actually check the type of data that's been stored into them. And it is quite good practice to actually check what type of data that you're working with, because making an assumption about what type of data is stored in a variable can be a little bit dangerous. And I'll demonstrate that to show you what I mean. If the age variable was actually set as a string data type, we're making an assumption that age is a number, because why wouldn't an age be a number? But if this variable was defined somewhere deep inside the code, or maybe it had been set by some other method, it could contain an actual string. So if we came down to, in our code, actually do something like this, you'll remember from a previous lesson that if we just want to add 1 to a number variable, we can say plus equals 1. And you can see we don't get an error, but in the right hand side of our console, you can see we've got an unexpected result. Instead of turning the number to 37, we've actually added 1 onto the end of the age string. And that's exactly how string addition works. We could do something like this, for example, say name plus equals, and then I'll put my second name on the end there. If you try to add something to a string, it just basically makes it longer by adding it onto the end. So this is what I mean by those unexpected results. Instead of getting 37, we've got 361. And I don't think I'm quite looking that age just yet. So what we need to do, if we are working with a string and we want to use it as a number, we need to convert that data type. And this process is known as coercion, where we take one type of data and convert it into another type. So there are actually lots of different ways to convert data types in JavaScript, and specifically if we want to convert a string to a number, there are a couple of different ways of doing it, but probably the best and the one that's most recommended is to use the parse function. And we've got the ability to parse an integer or to parse a floating point number. So if I just say age is equal to parse int, and then in the parentheses I pass in age, you'll see if I log out the type of age now, you'll see it's been converted into a number. And then when I add 1 to the value of age, you can see it increments to 37. So let's do a similar thing with the bank balance variable. You can see if I use the parse int function, we actually get a bit of an unexpected result. And what's actually happened is when we've run parse int against the bank balance variable, which has now been converted into a string, it actually just gets the whole number out of there, so we get 32. So when we come to add on the 0.75 to bank balance, we're only adding that on to the base number of 32. So what we actually need to use is the parse float function, which you can see when it's converted preserves the 0.35 after the decimal point. So before we finish this video, I'm just going to show you how to convert a number to a string. And there aren't many good reasons why you'd want to do this, but for instance, you might want to convert the number into a string, and then you can use some of the string properties, like the length of the string, to work out how many digits are actually in that string. So that's just one example of why you might want to do this. And similar to converting strings to numbers, there are several different ways of doing it, but probably the best way to do it for this example is to use a string function, and then we can just pass that in a number. And you can see in the console that this is coming out as a string because it's wrapped in the double quotes, but let's save it into a variable and check it with the type of operator. And as you can see, that final type of operator is giving us the result of string. So in the next lesson, we're going to look at some of the other methods and properties that are available with strings, and how you can work with strings in your JavaScript programs. In this lesson, we're going to focus on how to handle strings in JavaScript, and we'll mainly be looking at some of the functions that are available that are built in with JavaScript that enable you to transform the strings or to get certain information about them. So whilst we haven't covered what a function is within this course, if you just think of the code that I'm about to show you as things that are built into JavaScript that are available on any strings that you're working with, then hopefully that should be enough information for now to get going with these functions. So the first thing that you might want to know about a string is how long it is, and we can actually do that by just typing .length onto the end of a string, and you can see it returns with a number, which represents how many characters are in that string. So this is really common to find out the length of a string. You can find out if the string is empty. It will obviously return 0 if there's nothing in it. So it's another way of checking the data that's stored in your variables, and you can choose to do different things in your program depending on the result. So the next thing you might want to know about a string is what character is at a certain position. So you might have a need to find out what the third character of the string actually is, and we can do that by using this function called char@. And if I want to find out the third character of the string, which obviously is E, I actually need to pass in the number of 2, because the string is 0 indexed, which basically means that the first character in the string is at position 0. So this might seem a bit weird if you've never done any programming before, but trust me, you'll find 0-based indexes all over the place. So you just need to get into the habit of subtracting 1 from the actual position in the string that you want to access. Another thing you might want to find out about a string is, does it start with a particular sequence of characters? And you can do that with the starts with function. And starts with will actually give you a true or false value back depending on whether or not the string in question actually starts with those characters. So here we get one of those Boolean values that we talked about in a previous lesson. So if I was to change this to something else, I'd obviously get a false value back, and it is also case sensitive as well. So for example, THE with a lowercase t is not equivalent to uppercase THE. And of course there's a corresponding ends with function. Which does exactly the same thing as starts with, but obviously checks at the end of the string. So another common task that you'll need to do on strings is replace part of it. So we can actually identify part of the string by specifying a sequence of characters and then telling JavaScript what we want to replace that with. And the function we need to call is actually called replace. So if we wanted to replace the word quick in our string, we simply pass in one value of quick and then we put in the text that we want to replace the original. So you can do some very complex replacements using something called regular expressions, but we're not going to dive into that now because that's quite a complex subject on its own, as long as you know that there is a function called replace that allows you to replace text in a string. So when you think about working with strings, you might think about extracting part of a string or removing part of that string. And that is quite a common task, to carve up a string into different parts. And the function we can use to do that is called slice. So slice needs to have two numbers for it to work, and the first one is where we want to start in the string, and don't forget those strings are 0 indexed, so if we start off with a 0, and then the second number we pass in is where we want the string to finish slicing. So if we wanted the first 3 characters, we would pass in the number 3. And as you can see, that's got the first 3 characters from the string, and now we have THE in our console. Okay, so we said before that the starts with and indeed the ends with function are case sensitive, so we need to be careful about putting in capital letters in there. So one common technique is to call a function on a string to make it all either uppercase or lowercase. And that way you don't need to worry about case sensitivity when you're testing against other strings. So you can see the functions are 2 uppercase and 2 lowercase, and they will make sure that the string is all set to the respective case. So one final function that you can call on a string is the repeat function. And as the name suggests, it just repeats that string the number of times that you pass inside the parentheses. So there are quite a lot of other string functions that are available in JavaScript. These are just some of the key ones you'll need to get started with some basic problem solving. I'll provide a link with the details of all of the string functions that are available, but for now, in your console, if you practice some of these functions, so that you get confident in using them and understand what each one does, it'll get you ready for when you need to start writing some full JavaScript code. So with basic strings in JavaScript, there are a couple of problems that you might come up against. But in the last revision of JavaScript, there was a new feature called template literals, which addresses these problems. So what are these problems that you might encounter with strings in JavaScript? Well, the first one is that you can't have multi-line or spaces in between your strings. So for example, I've got a bit of dummy text that's been saved into this text variable here, and if I wanted to put a new line inside of it, you can see we get an error in our console saying that we haven't actually closed off our string, we've got an unterminated string. That's because we've added a new line and JavaScript thinks that the statement we had on the line above has finished, but it can't find the end of the string. So that's one issue you might come up against if you're dealing with large blocks of text. The other thing is dealing with quotes inside of these strings as well. So for example, if I wanted to put some quotes around this word, obviously the first quote I've added closes the string, and now the text in between the quotes is trying to be parsed as some JavaScript code, which it doesn't mean anything. So we can get around that by using double quotes for our strings as well, that's perfectly fine. And vice versa if we wanted to use double quotes inside a single quoted string. Or we could escape these quotes inside the string by putting a backslash before them. But this can be a lot of work, and remembering where all the quotes are or remembering to use the right type of quotes can cause you a problem. So the final problem is dealing with variables inside of strings. So it might be a case where we've got a variable and we want to add it somewhere inside our string. So let's say I wanted to add the name variable that I've created at some point in the string. What I would need to do is actually finish the string and then add on the name variable into the point where I've chosen in the string. And you can see that's now been added to the string on the right hand side. But this can get a bit complicated, especially if you've got lots of variables that you want to put at different points in the string. But luckily, template literals is something that solves all 3 of these problems. So a template literal really is just another type of string, and we define it not using quotes but using backticks. So you can see just by wrapping our text in the backticks, nothing's really changed, and our text variable is still holding the string. But now our first problem of adding new lines and whitespace inside the string isn't a problem. And also we can use any type of quotes that we want inside our template literal string. There's no need to escape them, which is handy because there's no need to escape them or do anything special when you're adding quotes inside a template literal. And the final thing of adding a variable inside the template literal, we can literally just make space down here. We can include our variable inside the template literal. The only thing we need to do is put a dollar and opening and closing curly braces. And then we just literally type in the variable name that we want to reference. And you can see on the right hand side, we don't display name, we actually put my name inside the template literal. And this just provides an easier way to actually put your variables inside parts of your text. So there are a couple of other features that come with template literals that are handy, but for the moment all you need to know is that you can use a template literal in place of a string, and it just makes life a bit easier if you've got blank spaces, variables or quotes inside your strings, and you don't really need to worry about doing anything special with them. So we've taken quite an in-depth look at strings over the last couple of videos, so we're now going to look at working with numbers and some of the math functions that are built into JavaScript. So in this video we're going to look at some of the things you need to be aware of when working with numbers in JavaScript, and we'll also look at some of the built-in JavaScript functions for doing some simple mathematical operations. So a few lessons ago when we looked at data types we came across the parseInt function and the parseFloat function. So if you remember, they take a string and they actually convert it into a numerical value. This is so we can do some mathematical operations like addition and subtraction on the number rather than actually modifying the string itself. So that's fine if you actually pass in a number inside of the string, but what happens if you pass something else inside there that doesn't contain an actual number? So if we pass cat, for example, you'll see on the right hand side the console comes back with NaN, which is basically short for not a number. So when you come across a bit of badly written JavaScript on a web page, sometimes you might see this, and it's basically when a bit of code on the site has tried to get some value from a string and there's actually no number within it. And even if there is a number in part of the string, if JavaScript can't work out where it is, then you'll still get this not a number response. But as you can see, if there is a number at the start of the string, JavaScript will take that as the value that you're trying to parse, and it will just ignore everything else in the string. So it's always good to be a little bit careful when you're using the parseInt or parseFloat functions, and you might want to check the response that you get back in case it's not the number that you were expecting. Another thing that you might want to know how to do is when you're working with floating point numbers, you can see when JavaScript displays it on the console, it actually removes any trailing zeros from the end. Which is fine because they don't need to be there, and if you're going to do any calculations it won't make a difference if it's not there, but if you're actually trying to display this to the user, you might want JavaScript to display that last zero. So we can do this by calling a function on the number, and the function is called toFixed. And the number that you pass inside the parentheses is saying how many digits do we want after the decimal point. And you can see now we're getting 15.70. And the more eagle-eyed amongst you might have noticed something about the result in the console, and that is that the value has been converted into a string. And we can actually confirm that by just using the typeof operator. So in order to display that last zero, JavaScript has converted 15.70 into a string, which is fine if we're just displaying this to the user, but then if you were going to do some more operations on the value, like some addition or subtraction, you'd have to convert it back into a float, or at least store this string as a separate variable. It's just something to be careful of if you are going to use this toFixed function within your code. So JavaScript provides you with a lot of built-in functions for dealing with mathematical operations. And these range from complex functions like dealing with cosine, tangent, hypotenuse and logarithmic values, all the way down to more common use things like generating random numbers. So we'll have a look at a few of those now, and you access these from the math object, which is present wherever you can use JavaScript. So one of the built-in functions we can access is the math.round function, and if you think back to being at school and you had to round numbers up and down, this basically takes a decimal point number and rounds it up or down to a whole number. So if I pass in the value of 1.2, you can see JavaScript returns a whole number of 1. Of course, if I put a number which is larger than 1.5, it rounds it up to 2, and indeed it also, if I put in a number of 1.5, rounds it up to 2 as well. So there are two other functions available which do a similar job to this but allow you to control whether you want to round up or down respectively. And they are math.ceil, short for ceiling I presume, and math.floor. So in these two functions, if I pass the value of 1.2, you can see math.ceil rounds it up, even though it's closer to 1 than it is to 2. It actually rounds that number up to a value of 2, and math.floor rounds the 1.2 down to 1. And if we were to change math.floor to say 1.8, you can see it always goes downwards and rounds it down to the lowest whole number. So those functions are really handy if you want to get rid of the decimal point from a number, and you've got several options there of when, and you've got complete control there if you want to round down or up. So probably the most common thing that people want to do with JavaScript numbers is to generate a random number. It's so useful for so many things, and luckily the JavaScript library has got this built in for us. So we can generate a number just by using math.random, but you can see the number it gives us back is a really long decimal number, and that's because math.random just gives us a number between 0 and 1. So usually that's not what we want. We usually want a number in between a particular range. So for example, if we wanted a number between 0 and 100, we would say math.random and then multiply that result by 100. And you can see I've got 59 here, but I don't really need the rest of the decimal value of the number. So we can use one of the above functions, math.round, math.ceil or math.floor, to actually round that to a whole number. And it's up to you which one you want to use depending on your use case, but I'm just going to go for math.round. And you can see this time it's generated a number of 51 for me, and that's a whole number that I could use somewhere else in my program to do something else. So one final function that's built into JavaScript that is useful for mathematical purposes is the math.absolute function. And all this does really is take a number in JavaScript and remove the negative sign if it is present. So for example, if I pass a value of -5, you'll see the result I get is just 5. And of course, if I just put a positive number in there, I still get 5. So this can be really useful if you want to work out distances or how far a number is away from 0. And you're not really worried about whether it's a positive or a negative number. So as with strings in JavaScript, there are a load more functions built in that you can make use of. I'll provide you with a link so that you can go through those when you have some time, but it'd be worth spending a bit of time in the console now having a go with these different mathematical functions, see if you can generate some random numbers, and when you feel confident with that, you can move on to the next lesson. In this video, we're going to look at arrays in JavaScript, and to understand what arrays are, you can imagine if you're asked to write a program to store several different numbers into variables, you might end up with something like this, where you're defining each variable separately and assigning the number to it. And there's nothing wrong with that. We've got 3 variables, num1, 2 and 3, and each has got its own respective number. But what if you needed to store 50 different values? How about 100 or even 1,000? It's fair to say that writing out all those variable definitions would be a bit of a waste of time. So arrays are used to deal with this problem, and you can think of an array as like a list, which basically holds a set of values and assigns it to one variable name. So generally, you'll create arrays with square brackets and each value is separated by a comma, like this. And when we reference the array of numbers variable, you can see we get that list of numbers returned. And it doesn't have to be numbers that you store in arrays, it can be any data type that's available in JavaScript. So here I've just created a variable called months of the year and assigned it some shorthand versions of January, February, March and April. So as you can see, it's a shorter way of providing a list of values to a variable name rather than creating several similar variables with different values. So if you want to actually access one of the elements from either of those arrays, we can simply type the variable name and then use square brackets to access one of the individual elements and then just specify the index of where that element occurs. And the same way we dealt with strings in a previous lesson, you can see that the array is 0 indexed, so if we want to get 1, the first element from the array of numbers, we need to pass in a value of 0 into those square brackets. So if we want to change a value that's in the array, we can simply reference its index again and assign a new value to it. So if I access the first element in array of numbers and give it a value of 10, you can see that now when the array gets printed to the console, the first value is 10, and when we access that first value using the 0 index below, that also gives us back a value of 10. Just as a note, when assigning values to an array, they don't actually have to be all of the same data type. So for example, I could change that to the word 10. And you can see that even though the rest of the values in the array are numbers, the first element in the array of numbers array has actually changed to a string. So as with strings and numbers in JavaScript, there are lots of functions built in that can help you manipulate arrays, and they're mainly focused around adding and removing elements from them. So we'll look at those functions in just a second, but as with strings, you can also find out the length of an array simply by accessing its length property. So if we want to remove an item from an array, there are two ways of doing it. We can either take one from the end of the array, for example the array of numbers that would be 9, or we could take one from the front of the array, so again that would be 1 in the array of numbers. And the function to take an element from the end of the array is pop. So if we call pop on the array of numbers array, you can see that the last item in the array 9 is returned to us in the console, and when we reference array of numbers again, you can see that the 9 has been removed and we're down to 8 elements in the array. So if you want to remove an element from the front of an array, you use the shift function. So this time when we call shift on the array, you can see that 1, the first element in the array, gets returned, and when referencing array of numbers again, you can see the 1 is no longer present in the array. So how about if we want to add values back to the array? Well, there are two functions available that do the opposite of what we've just done, and they are push and unshift. So you can see when the code runs again now in the console, when we call push, the number 10 is actually put to the end of the array of numbers. And then when we call unshift, 20 is placed at the start of the array. So between these four functions, you can actually control where your elements are being either removed or added to. And it's just a case of familiarising yourselves with what each one does and when you should use each one. And there are a couple of other functions which are really handy for helping you work with arrays, and the first one is slice, which helps you to extract part of an array. So you might remember the slice function on our string lesson, and it does exactly the same sort of thing. If we call slice on an array, we pass in a start value and an end value, and as you can see, I'm starting at the front of the array by passing in a 0 and just extracting the first two elements. But you can see slice is not destructive, it won't actually modify the array, because if I reference months of the year again, I've got the other two elements still present. There is another function though which is a bit more destructive, or constructive depending on how you look at it, and that is the splice function. So on first glance, splice looks to be doing exactly the same thing that slice is doing, but if we reference the months of the year variable again, you can see this time the array has actually been modified to remove those values from the array. So the reason why splice can be considered constructive as well is because we can actually use it to add values at a certain point in the array as well. So for example, we could add a new month in between January and February. And the second number that we pass into splice really determines whether or not we remove the item or not. So if I pass in a value of 1, it means we're going to remove one value from the array. But if I change that to a 0, you can see that now the splice function doesn't remove February, it literally just inserts that new month value in between January and February. So it would be worth your while spending some time now working with arrays if you go into your console and start using the push, pop, shift and unshift functions. And once you feel comfortable with those, move on to looking at slice and splice, and particularly with splice, how you can actually use it to insert items into an array, as well as removing items too. Once you feel happy with working with arrays, let's move on to the next lesson, which is working with objects. So in a previous lesson, we talked about the different data types that are available in JavaScript, and one of the data types that we didn't cover completely was object literals. So in this lesson, we're going to look at what object literals are, otherwise just commonly known as objects, and we'll see how to define them, how to use them, and why you would want to use them in your code. So objects in JavaScript are used to model actual things. So that thing could be a user, or a network connection, or possibly a HTML element on the page. So it's a way of grouping together some properties that that thing actually has and some actions that that thing can actually do. So let's go through an example. If I was going to model a user or a person, then I could actually create 3 separate variables such as their name, their age, and the programming languages that they're fluent in, and save those all in 3 separate variables. So like in our previous lesson with arrays, if we wanted to store multiple users or multiple versions of this data, we would need to create several different variables for each user. So for example, if we wanted to have one person, we could prefix all of the variables with an identifier such as person1, and then when we want to come on to the second person, we could do person2. But this is a really long-winded way of doing it, and we've got no way of keeping track of what properties, the name, the age, and the languages, are available on each person. So whilst arrays would solve this problem somewhat, we'd still need to keep track of which person is at which index in the array, and it gets a bit messy when we're trying to add, remove, and identify people at different parts of the array and the different properties that they have, because we would need 3 arrays to hold all this information. So objects will allow us to group this data together and access it easily. So we can assign an object to a variable in the same way that we can with other data types. And an object is defined with opening and closing curly braces. And inside those curly braces is where we put the properties that we want that object to have. So you'll notice that the property name is defined on the left hand side, so we have name, age and languages, and then there is a colon separating the value which is on the right hand side. And as you can see, we can quite happily put in strings, numbers and arrays, or any other data type that we have, including other objects, inside of our object properties. So simply referencing person at the moment gives us the whole object back, so you can see on the right hand side we've got all of the properties returned, but what if we actually just want to access the person's name? Well, there are 2 ways of doing that. There is the dot notation and the bracket notation. And the dot notation, as the name suggests, is just by using a dot or a period on the end of the object name and typing the name of the property that you want to access. So let's access the name property. And as you can see on the right hand side, we're just accessing the string property of name. And as you can see, we get the result on the right hand side. The other way to access properties is to use the square bracket notation, and it works pretty much in the same way. We just put some square brackets after the object has been referenced. You'll notice we have to pass a string into the square brackets, and this is just the name of the property enclosed in quotes. So the dot notation and the square bracket notation do exactly the same thing. The only real time that you'd probably want to use square brackets is when you want to access a property via a variable name. So here you can see I've defined a variable called property2get and given it the value of age, and then I can just use that variable name inside our square brackets to get a property from our object. So if I change that property2get value to something else, you can see I can dynamically access any part of the object just by changing the value of that variable. So now you know how to get the values of properties from an object, but how do you actually set or update the object properties themselves? Well, you can do that again using either dot or bracket notation. So here I've just used the dot notation to access the person's name property, and then I've just used an equal sign to assign it a new value. And if we examine the person object again, you can see when the console logs out the whole object, the name now has updated to Fred. And you can do exactly the same thing using the square bracket notation. And you can actually create new properties in the object whenever you like. So here I've created a new property last name, and you can see on the right hand side that the object has that new property of last name. So at a fundamental level, that's all you need to know about objects for the moment. You need to know that they can group properties together and you can access and set their values whenever you like. Before we finish, let's have a look at an example of an array of objects and how this would make our life easier if we were dealing with multiple people objects like we have in this example. So here we have an array which has been assigned to a variable called people, and inside the array are 4 objects that have the properties of name and age. So the first thing to notice is you don't need to create a variable name for each one of these people. So in the previous example we had a variable called person which stored our object. These objects are just created and stored directly in the array. So how would we access some of the data that's stored in our array? Well, in the previous lesson you saw that you could use an index to actually access an item in the array. So if we wanted to get the first item, we would say people and then square brackets 0. And you can see we've got the first item in the array returned. So now if we want to access one of the property values, we just use the dot or bracket notation to pick out the property that we wish. So here you can see how we're combining an array and an object together to store our data sensibly and concisely and then be able to access it easily with indexes and property names. So there's a lot more you can do with objects, and they can get pretty complicated when working on larger scale programs, but you should now have the fundamentals of being able to use objects, and in the next few lessons we'll look at how to use them in greater detail. So there are lots of times in your JavaScript code where you'll want to make a decision, and it might be showing a different message to a user or performing a certain action based on a condition. And like with most programming languages, in JavaScript this can be done with an if statement. But before we just get onto what an if statement is and how to use it, let's just talk quickly about coming up with a condition to base our decision on. So let's take a simple example. Let's say we've got a variable called bank balance which has a value assigned to it, and if it's below 0 we want to display a message to the user saying you're overdrawn, and if it's equal to or larger than 0 then we're going to display a message to them saying that they're in credit. So in a previous lesson we looked at the Boolean data type, and the condition that we're going to be creating will always result in a Boolean, so it's always going to be true or false. So that makes it really simple to decide which action to take. But we first need to come up with a rule to generate our Boolean value. So in this case it might be an example to create a variable called overdrawn. And we're going to assign that a Boolean value, but rather than just specifying directly true or false, we're going to create an expression, otherwise known as a condition, which will evaluate to true or false. So here I've created the expression of is the bank balance less than 0? And if we examine the overdrawn variable to see its value, you'll see it's stored the value of false because the bank balance is obviously greater than 0. If I was to change that to negative 20 though, you'll see overdrawn now has the value of true stored in it. So that's the first step to making a decision in JavaScript, is to come up with that condition and generate a Boolean value based on a certain set of circumstances. Now that JavaScript knows that our account is overdrawn, we can put together our if statement. So this is generally what an if statement looks like. We use the keyword if, and then in parentheses we put the result of our Boolean condition inside there. And if that Boolean value is actually true, then the code inside the curly braces will actually run. So you can see in the output on the right hand side we're still getting the you are overdrawn and you are in credit messages. And that's because both the code inside of the curly braces and outside of it is still running. If we were to set our bank balance back to 20 though, you'll see in the output on the right hand side that the overdrawn message is no longer displaying. And that's because when the if statement runs, we get the value of false in the overdrawn variable, and anytime an if statement encounters a false value, it skips over the code in the curly braces. So setting the bank balance back to negative 20, we have a problem because we're actually still displaying both messages. So if the user is overdrawn, we don't want to display the second message, and we can stop that from happening by adding an else statement as well. So you can see our overdrawn variable has a Boolean value of true, so we are seeing the overdrawn message, but the else statement is stopping the second statement that you're in credit from being displayed. So if we put in a positive bank balance now, you can see the code inside the if statement doesn't run, but the code inside the else statement does. So these if and else statements are all based on the Boolean condition, and we don't actually have to save that in a separate variable for this to work. We could actually just put this straight inside of our if statement here. And you'll find some programmers like to do the condition straight in the if statement, and some like to save it into a variable elsewhere. It's just a matter of style and preference really. As long as whatever you put inside of the parentheses for the if statement resolves to a true or false value, then your if and else statements will work as expected. Another thing you can do with if statements is to add additional tests inside of your else statements. For example, if the bank balance is larger than 20, we could test it again to see if it's above a certain value. So here I've added another if statement, another test on the bank balance value to see if it's larger than 1000. And if it is, we display a different message, but if it isn't, then we just display the you are in credit message. So if I raise the value of bank balance now, you can see that the second test for bank balance to see if it's greater than 1,000 is true, so it displays the message in the middle of our if-else block. So there's no limit to how many of these if statements or else statements you can add into your code. But as you can imagine, if you add more than one or two, it can get a little bit messy. We'll look at some different techniques that you can use to handle lots of these different tests in a future lesson. But before we do that, we'll look at how you can construct more complex Boolean expressions to handle more complicated scenarios. So in this video, I thought it'd be useful to go through a few different ways that you can construct Boolean expressions. That is, ways that you can make conditions that will test certain values that you have stored in variables, which you can then plug into your if statements to make decisions within your programs. So I've created 4 variables, A, B, C and D, and assigned them various values. And I'm just going to talk you through some of the most common operators that you can use in order to generate these Boolean expressions. So on the first line we have an expression that says is A greater than B. And if we were to directly compare those two values, we've actually got A and B both equal to 2. So the answer to that question that we're asking JavaScript is A bigger than B is false, because the values are actually equal. However, if you move down onto the second line, you'll see the expression we have is A bigger than or equal to B. So although the value that's stored in A is not bigger than B, but it is actually equal to B, the result that JavaScript gives us is a true value. So this is particularly useful when you're counting up to a number and you want to include that number within the range as well. But anytime you want to test for an equal value as well, you can just add an equals onto the end of the greater than operator. So for those first 2 lines, you can reverse the expression just by using the less than operator, which is simply the arrow pointing in the other direction. So moving on to the third line, we have a direct comparison here saying is A exactly equal to B. And you see that gives us the result of true. I'll explain the reason why we need to use 3 equals in just a second. But if you look at the line below, you'll see I have an expression where I'm comparing A to B, but saying is A not equal to B. So the exclamation mark followed by 2 equal signs makes up the not equal to operator. And as you can see, the result on the right hand side is false. So on the line below that, you can see I've done a comparison to say is A equal to C. So this time you'll note I've only used 2 equal signs. Now we're currently getting a false value back, and if you look at the values that are actually stored in A and C, you can see we're comparing a data type of number, which is equal to 2, which is stored in A, to a string data type of 1, which is stored in the variable C. So we're basically asking is the number 2 equal to the string 1? And we're currently getting a false value back, but if I change the value that's stored in C to a 2, you'll see the line with A is equal to C is now showing true. So that makes sense, we're comparing 2 and 2 and we're getting a true result back, but the double equal sign doesn't care about what data type is held in each variable. If we were actually to change that to a triple equal, you'll see it changes to false. And the short answer to that is the triple equals will test what type of data type is stored in each variable and will only return true if the data types are the same. So removing that third equal sign doesn't perform that check, and although the data types in A and C are different, the values they contain match, so the expression resolves with true. So moving on to the line below that, you'll see we're using that triple equal sign to check if D is equal to open, which is true because that's the string that we have stored in D. And it's just to highlight the fact that it's always best to use the triple equal sign where possible, just so that you ensure that you're checking the same data type that's stored in both variables. And then our final line, we've actually got an expression there saying is A equal to 1, which should actually be false because A is equal to 2 in the variable declaration above. But we've wrapped the expression in parentheses and then put the not operator in front of it, which is the exclamation mark. So that will actually inverse the response that we get from the expression. If I was to remove that not operator, you'll see the final response that we get is now false because A is not equal to 1. But just to highlight that the not operator is a really convenient way to invert the result of an expression. So in the next lesson we'll look at how to combine expressions together using and or operators. So in this lesson we're going to look at combining Boolean expressions together to handle more complicated scenarios. And the most common thing that you'll need to do is to chain Boolean expressions together with either an AND operator or an OR operator. and they equate to the literal English terms of and or. So it's like we're asking JavaScript a question and then adding additional criteria to that question. For example, is variable A equal to some value, and is variable B equal to another value? So we'll just run through some simple examples and highlight how the or and operator work. So again, I've got 4 variables declared, A, B, C and D, and they hold various different values. And then below that we've got some Boolean expressions, and I'll run through what each line means. So on the first line, we're comparing variables A and B, and the 2 symbols in the middle is the OR operator in JavaScript. So the question we're asking JavaScript here is A equal to true, or is B equal to true? So only one of those variables needs to actually be true for the overall expression to be true. And you can see on the right hand side, that's the actual result that we get from this Boolean expression. So as you can see, the OR operator is really useful if you want to test a variable to see if it's true, but also want to test another variable. And it's really useful if you have multiple conditions that you want to check and you only need to rely on one of those conditions to be true. On the second line, we're still comparing variables A and B together, but the 2 ampersands in the middle constitute the JavaScript AND operator. So it's kind of opposite to the OR operator in that both of those expressions, both of the variable values, need to evaluate to true. And if one or even both don't actually resolve in a true value, then the overall result is false, as you can see on the right hand side. So we would use the AND operator when we definitely need both of the expressions or the variables to resolve to a true value. So that's the basic usage of OR and AND, but you can see on line 3 that we can actually combine the AND and OR operators together. And this is where the ordering of the expressions and the operators can get important. So you need to be able to read a Boolean expression like this to work out what is actually happening. So if we break down line 3, you can see we're asking is A and B equal to true, but you can see above on line 2 we actually got a false value, but on line 3 we're getting a true result. And that's because we've also got an OR operator in saying is C bigger than 0, and because C is 1 then that resolves to true. And the reason this gives us a true result overall is even though B is false, the C is greater than 0 expression is kind of taking its place. So it might be clearer with this expression if we wrap some parentheses around the second part. So now if you think of the second part of the expression as being evaluated first, we're saying is B true or is C is larger than 0 true? Well, of course, the second part resolves in true, so we end up with a true value in A, and on the right-hand side of the AND operator, we get another true value from our expression in the parentheses. So that's why line 3 results in an overall true value. So on line 4, there's nothing too complex there. We're just basically saying is D equal to 0 and is C exactly equal to 0? And of course, because C is equal to 1, we get a false value there, and because the AND operator requires both of our expressions to be true, we get an overall false value. So this was just to highlight really that you don't need to have a true or false value already in a variable. You can actually construct your expressions on the fly by using operators within your statement. But as I said towards the start of the video, this is when it can start to get a little bit more complicated. And the final line on line 5 shows just how complicated it can get when we're working with all of those 4 variables, and we get a true value overall because all of the values are equal to what we've been provided with, because all of the expressions around the operators result in a true value, including the variable b, which has been inverted from false to give it a true value. So if you do find yourself chaining the AND and OR operators like this, there's probably a better way to achieve what you're trying to do. Or at the very least, you could actually store the result of some of these expressions into a variable, just so that your program becomes a bit more meaningful. So in the last few lessons, we've looked at if statements and how to construct fairly complex Boolean expressions. So now that you've got a bit more knowledge about expressions, it might be worth going back and trying out some more if statements with some of these more complicated expressions, just so that you know that you've got the hang of them. But when you feel comfortable with those, let's move on to the next lesson, which is all about repeating code. So there are going to be lots of times in your code when you want to repeat something over and over again, and you don't want to be writing the same JavaScript statements multiple times. For example, if you wanted to count from 1 to 10, you could just write out 10 console.logs, changing the number that you're printing out each time. So as we've seen a few times in the course already, if you end up repeating lines of code, there's probably going to be an easier way to do it. And in the case of repeating an action several different times, we have a programming feature in JavaScript called a loop, which allows you to repeat a certain number of statements for a certain number of times. And the two main ways to do this in JavaScript are using the while loop and a for loop. So let's have a look at how we would count from 1 to 10 in JavaScript using a while loop. So we're first of all going to define a variable that holds our starting number. So let's create a new variable called I and assign it the value of 1. Then to define a while loop in JavaScript, we use the keyword while, and then we open some parentheses and then some curly braces. So inside our parentheses, very similar to an if statement, we need to put a Boolean expression. So we need to say we're going to run our loop while this condition is true. So if we said while the value of I is less than 10, this means the code that's inside of the curly braces here until I is greater than or equal to 10. Because at that point the Boolean expression becomes false and the while loop finishes. So if we wanted to count to 10, you can see on the right hand side that the console.log is indeed repeating, but it's just actually printing out I over and over and again. And if you notice the error message at the top of the page, it's saying that the loop has timed out. Because as you can see in the result below it, I is always set to 1 and it's never actually getting any larger. So every time the while loop runs, when we get to the Boolean expression of is I less than 10, it's always going to result in true and it will never get to a false state. So to sort that out, we need to make sure that I is increasing in value, so we're going to add 1 to it on each loop that goes round. And we can just do this by incrementing I by 1. And if you remember from one of the previous lessons, we can also shorten this to say I plus equals 1. And you'll notice the output on the right hand side is now just displaying 1 till 10, and we don't get that infinite loop running indefinitely. So we could do the opposite as well. We could count down from 10 to 1. And all we need to do for that is to reverse the Boolean expression and set our starting value to 10. And of course we need to make sure that I is getting smaller each time, so we're subtracting 1 from it this time. So as you can see, while loops are fairly simple. We just need to make sure that we have a Boolean expression available to us and make sure that we've got some kind of terminating condition. And you can put as many statements as you like inside the curly braces. But generally, if you're putting in more than a few lines, you might want to break it down into other parts of your program. So now that you understand while loops, let's have a look at how a for loop works. So structurally, a for loop has all the same components as a while loop, organised in a bit of a different and neater way. For example, the first section in the parentheses is let I equals 1, and that's exactly the same as what we did with our for loop, but with a for loop it's actually inside our setup, inside the parentheses. But that's actually our starting condition, and that could be any variable declaration that you like. But it's common to use I or index just to keep track of how many times the for loop has run through. The second part of the for loop inside the parentheses is the Boolean expression. So this is exactly the same as what we had in our while loop as well, and it's basically saying that the loop will run whilst this condition is true. And the final part inside of the for loop setup is the modifier to make sure we don't get one of those infinite loops. So with the while loop, this was actually inside of our statements, but it's actually included inside of the for loop setup. So it makes it easier to create a loop that will run for a certain number of times. So if I actually get rid of the while loop now so we can see the output just from the for loop, you'll see it only counts up to the number 9. And that's because when the value of I gets to 10, the statements inside of the curly braces in the for loop don't actually run. So we can fix that quite easily just by saying in our condition is I less than or equal to 10. And it will actually run that final time when I is actually equal to 10. So now you've seen while loops and for loops, when would you use each one? Well, generally a for loop would be used when you know the amount of repetitions that you need to do. For example, you might have a certain number of items in an array that you need to loop through. Or similar to this, you might be counting up to a certain number. And when you do know the definite end condition, then a for loop makes sense because it's easier to write and easier to see what's going on. A while loop, however, is quite useful when you don't know what the end condition is. A simple example would be taking some user input and only kind of finishing the loop when they enter a false value. Or a more complex example might be where you're reading from a buffer or a stream and you don't know when the result of that is going to end. But it is useful to know both types, so take some time now to go and practice writing both for and while loops. And as mentioned, you can put any type of statements inside of those loops, so it doesn't have to be just counting up to 10. In the next lesson, we'll learn how to combine loops with using other data structures like arrays. So one thing that loops are really useful for is to loop through the items in a data structure, particularly an array. We might want to go through all of the items in an array and perform some action with them, or perhaps just display the contents of the array to the user. So to demonstrate this, I've got an array that has the days of the week set up in it. And you'll remember from the lesson when we looked at arrays that to access an item in the array we can simply use the square brackets and put a value inside that to access the item at that particular position. And of course arrays are 0 indexed, so to access the first element we need to pass in a value of 0. So that's fine for accessing one element, but let's loop through the entire array and print that to the console. So we'll set up our for loop and we'll set our initial condition by creating a variable called I and assigning it a value of 0. And as we saw, that will allow us to get the first value in the array. For our terminating condition, let's keep going whilst I is less than 7 because there are 7 items in the array. And then finally we'll increment I by 1 on each repetition. And we'll just log out the value that's stored in the array at that position on each loop. So instead of putting a literal value like 0 or 1 inside of the square brackets when we're referencing the array, we can actually pass in the value of I, and each time the loop goes round that will change, and that will then print out each item in the array in turn. So this works fine for the items that we've got in the array, but what happens if we add another value to it? Any items after the 7th in the array aren't displayed because our loop actually terminates when I reaches the number 7. So we could come into our condition and change this to 8, but if you remember, arrays have got a length property which actually tells us how many items are in the array, so if we access that, we can keep looping until I has reached the length of the array. And as you can see, the new item in the array is now displayed, and we can keep adding items and the for loop will grow as the array grows. So the technical term for this process is iterating or iteration, which is another way of just saying we're looping through the array and performing some action with the values inside it. Of course, there's nothing stopping you from using a while loop, and you can achieve the same thing as we have done here with the for loop. So up until now, the decision making we've been doing with JavaScript is based on one of these Boolean expressions. But JavaScript does provide another way of making decisions based on the value that's stored in a variable. And this is achieved by using the switch operator or switch statement. So in this video we'll take a quick look at how that works by using our days of the week and performing a different action depending on what day of the week is stored in a particular variable. So I have the days of the week array that we had in the previous video, and I'm just going to pick out one of those days and store it in a variable called today. And as you can see, the value of today now holds the value of Sunday. So to write a switch statement, we simply use the keyword switch, followed by some parentheses and then some curly braces. And inside the parentheses, you put the variable name that you want to test, that you want to examine, and then we'll do different actions depending on what the value of that variable is. So we're just going to pass in the value that's stored in today there. So currently the value inside today is Sunday, so let's print out a message if that's the case. So you can see we actually use the keyword case and then pass in a literal value after that, so we're checking for the existence of Sunday in our variable of today. And if we get a match there, we're actually going to log take a rest to the console. So that's the basic way that a switch statement works, but of course you can put in as many of these case statements as you like. But you might notice in the right hand side in our output we're actually getting the message take a rest and also go shopping as well. And that shouldn't really be happening because the value inside today is still set as Sunday, so when we get to the case of Saturday it shouldn't actually match that rule. And the reason for that is with a switch statement, when a case has been matched, every command after that actually gets run in sequence, which is quite handy because it allows us to run multiple statements if one of the cases is matched. But we do need to tell JavaScript when to stop executing commands and when to then move on and check the next case statement. And we do that by simply putting a break statement when we want that to happen. So you can see in the output now on the right hand side, the take a rest message gets displayed, but the second one doesn't because of that break statement stops any further JavaScript statements from running. So as I said, you can put as many of these case statements in as you like. So say for Monday through to Friday, want to display a message saying go to work. You could write a case statement for each of the days and display that same message. But the switch statement provides us with a nice way of catching any other values once we've provided our specific cases, and that's to use a default statement. So now if we change the value of day into one of the working days, you can see that even though we haven't specified Monday as a specific case, it's being caught by that final default case within our switch statement. And I guess technically you should put a break statement at the end of this, but as long as there's no more cases after the default one that you've defined, then this shouldn't really be a problem. So it's worth saying that the value that you pass inside of the parentheses for the switch statement can be pretty much any data type that you like, but it's commonly used with strings when you need to match a specific condition, and you need to perform some specific actions based on the string that's held within the variable. So that's it for this lesson. Join me in the next when we'll look at how to use functions to help you make reusable code. So we've seen previously that we can use loops to prevent repeating ourselves in our JavaScript code, but there's another feature that we can use that will help prevent us from repeating the same lines of code over and over again. And that feature is functions. So a function is just a set of JavaScript statements that you assign a name to, and then when you want to run that code, you just reference the name that you've given the function, otherwise just known as calling the function, and those lines of code within the function run. So let's go through a really simple example. So I've got two statements here. I'm defining a variable called name and then logging that as a message out in a template literal. So I'm going to put these two lines of code inside a function so that I can run them whenever I like. So you can see we define a function with the function keyword, and then the say hi is the identifier, the reference to the function that runs this code. And you can see there's an opening and closing parentheses, and I'll come on to a bit more about what that does in just a second. And then everything inside the curly braces is the code that runs when the function gets called. So you'll notice the output on our right hand side of our display has disappeared, and that's because although the function's been defined, we haven't actually done that calling process to actually run those statements inside of the function. So to call a function, you just use the identifier again, followed by the opening and closing parentheses. So we can call this function as many times as we like now. But at this point, it's not doing much more than what we could achieve with a for loop. So where functions really come into their element is when we provide them with a value, which slightly modifies the action that they take and provide a different output. So for example, with our small function here, we're always going to get the same output with the same message logged to the console. But functions allow us to provide parameters when we define them so that we can pass in different values. So with our function now, you can see I've removed the definition of the name variable and put that inside of the function's parentheses. And this is basically instructing JavaScript to say that the function say hi can accept one value and to store that in the variable called name. And you'll notice we don't need to use the var, let or const keyword to define that variable there. But the output on the right hand side is coming up as undefined, so name doesn't have any value at the moment. But we can change that by passing in a value when we call our say hi function. So now you can see on the output on the right hand side that each time we call say hi, the value of name gets set to whatever we pass into the calling parentheses. So although this is a really basic example, hopefully you can see the power of using functions and how you can customize the code that runs based on the values that you pass in. There are two other ways of defining functions that I'll show you now, but the way you call a function always remains the same. So another way that you can define a function is to first of all create a variable with the name of the function identifier. And instead of prefixing the identifier with the function keyword, we actually assign this the value of a function. So here you can see we've still got our say hi identifier, but we're actually defining this as a variable and assigning it the value of a function that does the same thing as we had it set up to do before. So this way and the previous way are the kind of traditional older ways of defining functions. And there are some subtleties in these two different ways of defining functions, but we won't go into that here. But it's worth familiarizing yourself with both of these ways, as you might see this kind of approach in older JavaScript code or older code bases that you might come across within your work. So the third way to define a function is to use the ES6 arrow function syntax. And that's very similar to using this second approach to defining a function, but we can actually just remove some of the keywords to make the function definition shorter. So the first thing we do is remove the function keyword, and after the parentheses with our argument in there, we put an equals and greater than sign. And you can see the output on the right hand side is coming out exactly as it did before. And because we're only using one argument in our function, we can actually also remove these parentheses too. So some programmers have different approaches. Some like to leave the parentheses around there, and some like to make their code as short as possible. So have a try with both approaches and see which suits you. So the reason these ES6 functions are called arrow functions is because the equals and the greater than sign obviously looks a bit like an arrow, and they can sometimes be called fat arrow functions. So another really powerful and commonly used feature of functions is to actually return a value from a function to be used elsewhere in your code. So let's take a look at how that works now. So let's create a function that adds two numbers together. And we'll take in two arguments, num1 and num2, which will represent the two numbers that we're going to add together. And I'll use the arrow syntax to define our function. So notice I have to put the parentheses around the arguments because you can only remove them when you only have one argument. So let's add those two numbers together. And if we were to write a console log here now, we would see the result of those two numbers added together. But we want to pass the value back to wherever the addNumbers function was called from. And we do that by saying return and then the value that we wish to return. So let's just test the addNumbers function out. So here you can see we're calling the addNumbers function and passing in 2 and 2, and then the result of that is returned from the function and assigned to the variable called result, which we then log out to the console. So this is massively useful because now when we want to call our addNumbers function, we can pass in different arguments and store or use the value that addNumbers returns from wherever it's called. So again, this is a really trivial example, but hopefully you can see how useful this will be when you start writing more complicated code. There is just one last thing to know about functions, and that is when you're using an ES6 arrow function and you're performing a simple calculation or a simple operation like we are in our addNumbers function, you can actually shorten the code and remove the return statement by using something called an implicit return. So really we don't need to store the result of the calculation in the variable total, we could just return that calculation on this line here. Which means we can then get rid of this line here. And when you end up with a function like this with an ES6 arrow function, you can actually remove the return keyword as long as you remove the curly braces as well. So again, this might be down to your style and your personal preference of how you can easily read the functions that you define. But this sort of abbreviation and simplicity is encouraged by a lot of JavaScript style guides, so it's probably best practice to take this approach where you can. So we've covered a lot about functions in this lesson, but in the next lesson we'll look at something called anonymous functions. So in the previous video we saw how functions work, how you can define a function and how you can then call a function with different values. And in this video we're going to look at something called anonymous functions. So we did actually come across anonymous functions in the previous video, I just didn't point it out so that you didn't get confused when learning how to define your first simple functions. So here you can see the function that we had in the previous video, slightly amended, to just display hello world to the console when the say hi function is called. And you can see the function that's defined on the right hand side of the equals sign doesn't actually have a name, it's the variable name of say hi that we use to identify the function. So this is an example of an anonymous function because it doesn't have any direct name itself. And I'm going to highlight this point by using an actual built-in JavaScript function called setTimeout. So setTimeout is a function that waits for a certain amount of time and then actually calls another function. So the setTimeout function takes two arguments. First of all, the function that we want to run, and the time to wait before it actually gets called. So the time is in milliseconds, so if you pass a value of 2000 into there, that's actually 2 seconds. And the function name, let's actually replace that with our function and call say hi. So if you look in the console on the right hand side, after 2 seconds, the say hi function gets called and hello world gets logged out. But our say hi function isn't very useful and the chances are we won't want to call that anywhere else in our code. So instead of setting up that identifier of say hi, we could actually just pull out that anonymous function and pass it into setTimeout independently. And as you can see, after 2 seconds in the console, the message is logged out. So hopefully you can see an anonymous function can be just dropped in anywhere else where you would be expecting a function definition. And certainly when you start working with the browser and HTML elements and events, anonymous functions are used extensively. But for now, if you just have an understanding that an anonymous function can be dropped into wherever a function definition is used, then you won't get confused when you see functions being used like this and they have no visible identifier. Of course, if you prefer ES6 arrow functions, you can of course use those as anonymous functions as well, and if there are no arguments, you simply use an open and closing parentheses in place of that function keyword. So we'll revisit functions and anonymous functions when we start looking at the browser, but in the next lesson we will look at JavaScript classes. So in this lesson we're going to take a look at JavaScript classes. And in a very simple term, a class in JavaScript is kind of like a blueprint for an object, in that we can model a real thing and specify the properties that it has and the functions that it can perform. So there's quite a lot to know about JavaScript classes and how the prototypal object inheritance mechanism works, and we could probably put a whole course together on the intricacies of how that works. But as this course is focused on the essentials of JavaScript, we're just going to have a high-level overview of what classes are and how you might use them within your JavaScript code. So let's start off by defining a simple class. And what we've defined is kind of like a souped-up function, in that we've defined some code, but it won't actually do anything until we run it. But whereas with a function, we call it by referencing its name, with a class, we actually create a new object in a process called instantiation by using the new keyword. So let me explain the code that we have here a little bit. We've basically defined a class called person and set up a variable inside it called name. And after that, we've created a new variable p and we've assigned it a new object based on the class of person. And if we were to inspect that p variable now, you'll see it looks very much like an object in that we've got a property of name and it's got a value assigned to it. And we can check that p is actually an object by using the type of operator. And as you can see, it is actually an object. But you'll notice outside of the object curly braces, we have the type of class that we've used to create our object. And in this case, it's person. And there is another operator that you can use to check what type of object you have created, and that is the instance of operator. So here you can see by writing a statement that p is an instance of person, we get a true value back. So what about if we want to access the value of the variable that's inside of our person class? Well, we don't actually reference the person class directly, we reference the created object or the instance of person which is stored in our p variable. And as with other objects, we can just use the dot notation to access the property that's created in the object. So one really useful thing with a class is we can define functions inside it that we can then call in the objects that we create. So here I've created a function called sayHi, which should just log the name variable out to the console. And notice within our class we didn't need to use the function keyword anywhere. And that's a nice feature that was introduced in ES6, which just makes our class definitions a little tidier. So if I want to call the sayHi function on the person object that we've created, you can see I can call it just by referencing sayHi on the p variable which contains the object that we've created. But you'll notice in the output on the right hand side that the name variable is actually missing from the console log. And that highlights a really important part of using classes in JavaScript, and that is that we need to use the this keyword to reference functions and variables that are associated with a particular class. So you can see when I change the console log to this.name, the name actually does get displayed in the sayHi function, and that's required when you're referencing variables and other functions that are associated with this person class, as it helps JavaScript to keep track of which variable it should be using in which position. So this is one of the things that can make classes in JavaScript really complicated. But as I said, we're going to keep it simple for this lesson, so as long as you understand that you need to use the this keyword to reference any variables or functions that you define within the person class, then you should be okay writing basic classes in JavaScript. So there's one more thing we can do to improve our person class, and that's to remove the fixed value that we've got stored in the name variable. so that we can say hi to different people. So we could, of course, in our function here, put in an argument so that we can actually change the output of the console.log. That would kind of make the name variable above a bit redundant. And when you create your classes, you want to be able to associate certain properties to the objects that you create. So a better approach to solving this problem would be to use a constructor. So a constructor is just a special function that gets called when the object is created. So at this line down here, when we actually create a new person, this constructor function will run. So we can pass in values to the constructor. So the constructor will now accept one value and store that into the variable name. And if we assign the value that's passed into this.name, this will set the name variable in the overall person class to whatever's provided in the constructor call. So currently we're not providing any value, so let's put something in there now. So now you can see when we're creating our new person object, we're passing in a value which is then picked up by the constructor, and inside the constructor function, we're saving that value in this.name on that particular instance of the person object. So as you can see, when the sayHi function is called on the person object, we get the new name in the console.log. So using classes has a lot of similarities with functions, but instead of creating blocks of code that can be run by calling your function, you're actually creating new objects that can have many properties and functions themselves that you can then use in other parts of your code. So as mentioned at the beginning of the tutorial, this is a very high level and simple overview of classes, but this should give you the basics for starting to write JavaScript classes. In this lesson, we're going to look at how to get the date and time in JavaScript and how the JavaScript date object works. So getting the time and date, or working out the differences between times and dates, is a common thing that you'll need to do in your JavaScript code, especially when you're displaying information to the user, for example. So if you've done any other programming in other languages, you might have come across simple functions that you can call to get the current date and time. But JavaScript doesn't make it particularly easy to get this information. And you first of all need to create a date object and then call various functions on it to get the information that you need. So let's have a look at how this works. I've created a new variable called date, note the lowercase d, and then I've created a new date object using the new keyword that we came across in the classes exercises previously. So if we were to log date out to the console, you'll see it looks a lot like a string, but if we actually try and perform any string type operations on it, like for example to turn it to lowercase, you'll see we get an error, and that's because date isn't actually a string, it's an object, and we can confirm that by using the typeof operator. So in the same way that we created our own classes in the previous lesson and then instantiated them to create our own objects, what we've done here is actually create a new date object. So let's look at how we might use the date object that we've created to get the current time. So you can see in the output that we get on the right hand side that we've got 20, 14 and 36, and each of those correspond to the current time, which is about 8:15 in the evening. So you can see we don't actually have just a simple getTime function on the date object, we need to actually extract each part of the time itself, that is the seconds, minutes and hours. And then if we were going to display this to the user, we might wrap the result of this in a function and then put it in a template literal or something similar to display it. So how about if we actually wanted to get the calendar date? So getting the calendar date is even more confusing really, because we need to call completely different functions for the name that you would think we're getting. So for example, to get the date of the month, we need to call the getDate function. So that's the actual day of the month that we're in at the moment. And the second function we call is getMonth, which actually gets the number of the month of the year. And you can see we've got a 3, which would indicate March being the third month, but that's actually 0 indexed, so we're actually in April while this has been recorded. So we actually need to add 1 to that to actually get it in the right place. And then finally, instead of calling just getYear, we need to call getFullYear, which you can see gives us back 2019. And there is actually just a simple getYear function, but that actually returns something completely different. So at this point you might be thinking there's lots of different functions to remember, and when you're learning JavaScript you're not going to remember all of these off the top of your head all the time. But luckily there's lots of references for finding out these functions and what they do and what they return, which you can find online. But the key thing to remember is that you'll need to call the individual function for each section of time or date that you want to retrieve. So within our date constructor you can actually pass some values into it as well. So here you can see I've passed in the date of August 26, 1982 as a string, and you can see when we try and get the parts of our date, we get the exact same values back out for each corresponding date item. Of course the hours, minutes and seconds is 0 because we didn't specify that in the string when we constructed our date. So passing strings to the date constructor might be commonly done when you've received stored information from a database or an API call, and then you want to format that date for the user. It's worth noting as well that for every get function that's available on a date object, there is actually a corresponding set function as well. So for example, if we wanted to change the date after the date object's been created, you can see we can call the setDate function, which actually updates the day of the month, and then when we call the getDate function just below that, you'll see it's been updated to 30. So now hopefully you've got a good idea of how you can start working with dates and times in JavaScript. So I did mention before that there isn't a simple getTime function that's available on a date object. Well, that's not strictly true because there is actually a getTime function that exists. However, it doesn't actually do what you think it might do. The natural assumption would be that it would get the current time, but what the getTime function actually returns is the long number that you see on the right hand side. And this is what is commonly known as a timestamp. And a timestamp is basically the number of milliseconds that has passed since the Unix epoch, which, if you've never heard of that before, is basically the date of the 1st of January 1970. So the Unix epoch is something that's commonly used across a lot of computing systems so that we can get a standardized time when comparing dates and date objects across different systems. So timestamps are really helpful for working out how much time has passed between two date objects. For example, if I create a new date object which is set to today, and then subtract the timestamp from the date that we created back in 1982, we can work out how many milliseconds have passed since that date back in time. So whilst this might not seem super important right at this moment, when you start dealing with user content on a web page, for example things like comments that a user has posted, then working out the difference between dates when things have happened becomes more important. So that's it for this lesson on working with the date object. In the next lesson we're going to look at variable scope. In this lesson, we're going to talk about variable scope and why it's important to understand it when writing your JavaScript code. So quite simply, variable scope is where you're allowed to use your JavaScript variables, or at least where you're allowed to use them and get the expected result. So the place where you actually define your variables determines its scope and can restrict your ability to where you can actually reference that variable name. So I'm going to illustrate this using a few simple examples. So the main thing I've created here is a variable called name and also a function called sayHi, which actually has another function inside it. And as you can see with the output on the right hand side, the sayHi function is quite happily outputting the first console.log. And if we were to go inside that function and call the askQuestion function, you can see that quite happily works as well, including the value that's stored inside name. And we should probably have a question mark on there, being as it's a question. So everything works with our two functions because the value of name is actually defined outside of those functions and so has a scope of the entire program. So if you think of it from a hierarchical point of view, because the name variable is defined outside of the sayHi function, it's available inside it and also to any functions that are defined within the sayHi function. So what about if we move the name variable inside of the sayHi function? You can see nothing's changed, the name variable is still available to those two functions, but what happens if we try and log out the name variable itself outside of the sayHi function? Because it doesn't exist outside of the sayHi function, we don't get any result. So the key message here is that you can only reference variables, or at least you can only get their values, from the scope in which they're defined. So the same thing applies to functions as well. So if you look at the output on the right hand side, you'll notice we get an error because we can't call the askQuestion function outside of the scope of where it's defined. Just as a final example, if we were to move the variable of name inside of the askQuestion function, you'll see the first console.log inside of the sayHi function now no longer has access to the name variable, so it just prints out the message hi without the value of name. So there's quite a lot more to understand about variable and function scope, and this is particularly true when working with objects in JavaScript. If you remember, in a previous lesson we briefly touched on the this keyword, which is used to reference an object that's been created, and this can form an important part of dealing with scope within objects. And this can form part of the variable and function scope when dealing with objects. But for now, you just need to know that variables have a scope of where you define them and where they can be used. So this might be a good opportunity in your own JavaScript environment to define some functions and some variables and move them around and see where you can't access them. So no introductory series to JavaScript would be complete without talking about some of the functions that are built into arrays. And because arrays are one of the most commonly used data structures, it's hard to imagine a bit of JavaScript code that doesn't use an array in some way or another. It's really useful to know these built-in array functions. So I'm going to run through 4 of the most common array functions now and demonstrate how you might use them. So the first function is the forEach function. So to use the forEach function, we simply access an array, so I have an array of numbers here, which is literally called numbers, and then after referencing the array we say .forEach. And inside the parentheses for the forEach function we actually pass another function. And I've actually used an ES6 arrow function here, but this equally could be a function declared with the function keyword. So what can we do inside of our code in the forEach function? Well, you'll notice that the arrow function actually accepts one argument, which is number, and that will correspond to each item in the array as the forEach function loops over each number. So thinking back to a previous lesson with variable scope, the number variable is now accessible inside of our arrow function. So we might do something simple like this with it. So you can see the arrow function itself is called 10 times, once for each item in the array, and each time it is called, the variable number receives the value of the item in the array. So forEach is really useful when you just want to loop over an array like you would do with a for loop, but you're not actually too worried about modifying the contents of the array, as if we inspect the numbers array lower down, you'll see none of the values have actually changed within the array. So let's look at our next array function. So the second array function we'll look at is the map function, and this has got the same format or syntax as the forEach function did, in that we pass in a function inside of the parentheses. But with the map function we do actually need to return a value from the function that's inside of those parentheses. So let's just return 1 for example. And you should notice in the output on the right hand side that we've still got 10 items in the numbers array, but they've actually been mapped, or rather changed, to the value 1. So what the map function allows us to do is loop through all of the items in an array and change their value in some way. And it's common to apply some kind of modifier to the actual item in the array. For example, we could multiply all of those numbers by 2. So this is really useful to make a global change to the values in an array by applying some kind of modifier. And if you remember a few lessons back when we talked about functions, there's a way that we can actually make our arrow function a little bit neater. And that is to use an implicit return, which basically means we can remove the return statement and the curly braces from our arrow function. It's worth noting that the map function itself, although it does change the values in the array, it doesn't save it back to the variable that it was called on. So for example, numbers is still equal to the original array that we defined. So if you do want to save the result of a map, you would need to assign it back to the same variable or a new one. And of course, because numbers is defined as a constant, we can't do that here, so we'd either need to define a new variable or change const to a let. So let's have a look at another array function, and that is the filter function. So the filter function actually removes values from the array based on a Boolean condition. So example, in our fat arrow inside of the parentheses, if we were to return false, this is telling the filter function to remove every item in the array, and you'll see in the output on the right hand side that the array then becomes empty. Whereas if we were to return true, you'll see every item within the array is kept. So really with the filter function we need to pass in a Boolean expression that meets some kind of criteria to remove some items but not others. So because we have access to each item in the array based on the number variable that's passed in, we can return number is bigger than 5, which will only be true for 6, 7, 8, 9, 10, which are the items that are left in the array. And of course we can make that into an implicit return as well. And that expression can be as simple or as complex as you like. So as you can see, this is a really useful function if you want to remove unwanted items from an array. So an example common use is to remove null or falsy values from an array before that data is sent somewhere else. So the final function we'll look at is the reduce function. So the reduce function is a little bit unique because it actually takes two arguments into its function callback. So the first argument is the accumulator and the second is the item in the array. And in this example I've called the accumulator accumulator, but you can call this anything you like, and often people shorten it to ACC for short for accumulator, or maybe even just A. So with the reduce function, what the accumulator does is it holds a running total of values. So instead of reduce returning an array, it actually returns a single value. So for example, if we wanted to add all of the numbers up that are inside of the array, we could just return from our function the value of accumulator plus the number, which will in turn be each item in the array. So this has the effect of adding all of the numbers in the array together and then returning the result. So whilst this is a good example of adding the numbers together, there's lots of other different uses for reduce. So for example, merging arrays or objects together is something that this could be useful for. So those are 4 array functions that are available to use on any array in JavaScript. There are actually quite a few more functions that you can make use of within your code, but these are some of the key ones that you'll use on a day-to-day basis, and you can see the format of them is very similar. So once you've got familiar with these 4, using other ones won't be too tricky. Near the start of the course, when we were looking at working with strings, we came across the replace function, which as the name suggests will find some values within a string and replace them with whatever you pass in. But there's often a need to remove values or replace values based on a pattern rather than a literal string. So if we wanted to remove the number in the text variable, the replace will fail if the number in the string changes somewhat. So a better way would be to tell JavaScript to remove any numbers that are in the text variable. And we can do this by using a pattern matching system known as regular expressions. And regular expressions are something which could do with a whole course of its own to fully understand. This lesson will just give you a brief introduction to what they are and how you might use them within your code. So within our replace function, instead of passing in the literal string of 123 123, we're going to use a regular expression. And you define a regular expression with 2 forward slashes, and the contents of the expression itself goes inside of those. So here you can see we're matching the pattern of 1, 2, 3. And because the number 4 doesn't fit within this pattern, the regular expression stops working and no more values are removed. We can ask the replace function to check everywhere within our string for the pattern of 1, 2, 3 by passing in a modifier after the second forward slash, which is G for global. But of course, if we were trying to get rid of all numbers from the string, then we'd want to pass in a 4 as well, but that actually presents us with a problem, because this pattern of 1, 2, 3, 4 matches the first 4 digits within the number, but then the pattern fails for 1, 2, 3 because we don't get a complete match. And of course it's not much better than what we had in the first instance of just passing in that literal string for the replace function to find and then remove. So regular expressions provides us with a way of just matching individual digits and numbers. And we do that with something called a character class, which is the square brackets that we have and then a range of numbers. So our pattern is to match any number between 0 and 9 and then remove it, and of course because we have it set as a global search, it finds all of the numbers in the string and removes them. So we can do a similar thing with letters as well if we want to remove them. So here you can see we're left with the remaining numbers that haven't matched the pattern of being a character in the range of A to Z. Another thing we can do is match spaces within our string. So a backslash followed by an S means match any white space within the string, and you can see the space in the centre of the string is then removed. So that's really useful if you just want to remove any white space within the string itself. So if we were to put some more space at the front, or even in the middle and at the end, you can see no matter where it is, all of that space gets chopped out of the text variable. So those are just a few simple patterns and some examples of when you might use a regular expression to remove parts of a string. There are of course lots of other examples where you can use regular expressions, like checking a user has entered a valid email address. But those expressions are much more complicated than what we've seen here. So there are lots of great resources online for learning regular expressions, and I'll put a few links in the description below if you want to take it further to find out more about pattern matching. So there might be time when you're writing your JavaScript code when you experience an error. And that's fine if it does happen. Sometimes variables don't receive the correct value, or the user inputs some data that causes your program to behave differently, or you receive a response from a server that isn't expected, and the code you've written just isn't able to cope. So whilst that isn't a problem in itself, experiencing an error will actually stop the execution of your JavaScript code. So for example, in the code that you can see on the screen, I've tried to call a function called sayHi, which actually isn't defined, with a variable name that's not actually defined. And you can see we get the error in the console on the right hand side saying exactly that, but the console.log underneath it doesn't actually run. So JavaScript provides you with a way of testing some of your code to see if it actually produces an error, and if it does, to actually handle that error gracefully. And we do that in JavaScript using a try-catch block. So try and catch are two JavaScript keywords, and as you can see, they're followed by some curly braces. So inside the try curly braces, we can actually put in code that we're not sure whether it's going to work, or there's a chance that it might generate an error. So as soon as we move our call to our non-existent sayHi function within the try block, the actual console.log that was failing to run earlier is displayed OK. And that's because any errors that occur within our try block are passed to the catch, and the value of that error is passed to the error variable inside those parentheses. So rather than leaving the catch block empty, we could display a message to the user to let them know that something's actually gone wrong. So this would be useful to let the user know that something isn't quite right, but we'll still let the rest of the JavaScript code continue working. And if you're interested in what's stored inside of the error variable, you can see it contains the notification that the sayHi function is not defined, but there's a whole lot of other information in there as well. And that's something called a stack trace. And a stack trace is used to identify at what particular point the error occurred. And it looks a bit confusing and cryptic inside of Run.js because there's a lot of other underlying JavaScript that's running in the background. So don't get too frightened at just looking at that output there. Chances are if you're running a small program or running in the browser, the actual stack trace that you get will be a lot more minimal than this. So you'll use a try-catch block wherever you think an error may occur, or if you identify an error occurring within your code, you can go back and wrap a try-catch block around it to make sure the rest of your code continues working. So that brings an end to our JavaScript Essentials training course. We've covered everything from the basics of logging information out to the console, to working with numbers and strings, to creating objects and working with arrays and their various functions, all the way up to dealing with more complicated things like working with JavaScript classes and regular expressions. There's lots of places that you can go now with your JavaScript knowledge. You can look at applying these skills to the browser. So if you're working on designing and building web pages, you can use JavaScript to work with the document object model, or DOM, to update various parts of a web page and provide some life and interactivity to those pages. Another option is to start looking at Node.js, which is JavaScript working on the server side, which is the same JavaScript that we've been looking at, but focused more on dealing with network requests, working with files, cryptography, databases, and many other things as well. Whichever way you go, all of the JavaScript knowledge that you've gained from this course is still applicable and will help you out. So don't be afraid to come back to these lessons at any point in time, just to refresh your knowledge, because having strong knowledge of JavaScript Essentials is key to mastering other areas of web development. I hope you've enjoyed this course, and I look forward to seeing you in the next Essentials training course.